Okay, I'm going to do a few more long division problems. And the examples I'm doing come from the review. So this is more on long division. Okay, more on long division. Long division is in 4.7. This is that part 2. There's some homework you're going to do after you get through watching the videos. So I'm going to add this one to the assignment that says My Videos. So more on long division, 4.7 part 2. These are the 3 problems on the review chapter 4. Okay. All right, so they come from that last page. All right, so the first one had 4z minus 3. My z is going to have that extra little mark in it so it doesn't look like a 2. Oh, and the way it started, it looked like this. 4z squared minus 19z plus 12. Okay, this is 33 from the review. All right, so I've got to divide 4z minus 3, but see how that's got 2 terms? So I don't just write that up underneath each one. I'm going to take the 4z minus 3 and actually set up a long division problem. Okay. All right, now, next thing, we'll get started. So let me go ahead and remind you of the 4 steps we're going to do. First thing we're going to do is divide. Next thing we're going to do is multiply, and I like to add the word back. We're going to multiply back, okay, times this 4z minus 3. Third thing we're going to do is subtract, and we're going to do it. Polynomials are a little harder than when we did our numerical example. We're going to subtract by changing the signs and adding. Now, so I'm going to change the signs because if you subtract, it's like you have a -1 that needs to be distributed throughout. So the signs would change. And then I am adding, but be aware that sometimes adding feels like subtraction, because if I wind up having something like a 5 up here, okay, like maybe a -5 up here, and then I have a 3 down here, even though I'm adding, that's going to turn out to be -2 because I'll have to take 3 from 5, and then it would be negative because 5 is the bigger number, okay? All right, and then after we do the subtraction step, that's the tricky step, okay? After we do that, then we go in, and step 4 is just to bring down the next term. Okay. And then we just go back up, do the whole thing over and over and over again till we're through. All right, now on this one, it's degree 2 on the top, degree 1 on the bottom. Okay, so that means we're going to have to go 2 rounds. 2 divided by 1 is 2. That means I'm going to have to do this sequence of steps twice before I'm finished. Okay, so the first step will be to divide 4z into 4z squared. I'm going to do my scratch work over here to the side in case you want to do that. Okay. All right, so the 4's would cancel. And then remember that z squared is z times z. So one of those z's would cancel, and all you'd have left is z. All right, so the z I'm going to put right here above the term that has a z in it. Okay, now I need to multiply z times the 4z minus 3. So I said multiply back to try to remind you that you take z and multiply it back times this 4z minus 3 right here. I'm going to go ahead and show the scratch work. When I do that, the z gets distributed. Okay, and I get 4z squared minus 3z. Now, it's really important when you do your long division that you just kind of follow the process and don't jump ahead thinking about what you expect or what you're hoping to see, but just kind of let it happen as you go through the process. All right, so that's the multiply back step. So we've done that one and that one. Now is when we're going to do the subtraction. Okay, so we're subtracting this whole polynomial. So it's like we're going to take that -1 and we're going to go and distribute that throughout. Okay, so when we do that, distribute that -1 throughout, this positive 4z squared becomes negative. The negative 3z becomes positive. The signs change. All right, so now that we've done that, changed the signs, we can add straight down. This is gone. And then a negative 19z and a positive 3z. So you pay attention to the positive on the 3z now. Negative 19, positive 3, that would be negative 16z. Okay. All right, then we're going to bring down the next term, and then we're going to go again. All right, so this is the place to be careful. This is where people will put negative 22z, or they'll put like positive 16. Okay, so you have to really watch it right there. So this step right here is kind of like the problem earlier on the test where I had you subtract vertically. And when you do that, you can go through and change the signs to distribute the -1 throughout, so that your brain can be thinking about these as adding integers. Okay. All right, so now let's do the next round. So now I've got to divide 4z into the negative 16z. So I'm ready to do the scratch work for that. So I'm going to take the negative 16z divided by the 4z. See how the z's cancel? I wind up with just -4. Well, that's going to go right here. Then I'm going to take the -4 and I'm going to multiply it back times the 4z minus 3. And when I do, I get a negative 16z plus 12. I'm taking the -4 times the 4z and getting negative 16z. -4 times -3 is plus 12. Okay. All right, so we finished the divide and the multiply back step, so we're on that subtraction step now. Okay, I'm going to change colors back now. So now, since I'm subtracting this bottom polynomial, that subtracting a negative 16 would turn that into a positive, and then subtracting 12 would make that a negative. So this one's a little unusual because this cancels out or becomes 0. This is 0. There is no remainder on this one. Okay. All right, so this is kind of like just dividing 2 into 6. It went evenly is what they sometimes say. There's no remainder. So your answer, if you're doing 6 divided by 2, your answer would have just been 3. So on number 33, your answer is just the z minus 4. Okay, and that would be it. Okay. All right, let's try the next one. The next one is going to be a little more interesting, so hopefully. So let's take a look at 34. All right, so on that one, I have 3x minus 5 in the denominator, and then 15x to the third minus 16x squared minus 21x plus 10. And it's written like that. So good way to think about it is that you're just, in a way, changing almost like an improper fraction to a mixed number. You're doing that by dividing. So I'm going to take the 3x minus 5 and get ready to divide that into 15x to the third minus 16x squared minus 21x plus 10. All right, so my first step would be to divide the 3x into the 15x to the third. And you can do the scratch work over here on the side, because sometimes it's helpful when you're new to this to be able to look at it and see the 3 going into the 5 and knocking out one of the x's. So that's 5x squared. That would go right here. Okay. Now you're going to do the multiply back step, where you take that 5x squared, multiply it back times the 3x minus 5. So there's some distributing going on. 5x squared times 3x would be 15x to the third, and then 5x squared times negative 5 would be minus 25x squared. Okay, so when you do the 5x squared and you multiply it back, you got 15x to the third minus 25x squared. Okay, so that's the multiply back step. All right, the third step is when you do your subtracting. So you're subtracting that second polynomial from what you see above. Okay, so subtracting the polynomials. So we're going to do minus this, and then minus a negative 25 would become positive. So now we can think about adding 15x to the third and negative 15x to the third, and that would cancel out. That would be 0. And then a negative 16x squared and a positive 25x squared would become 9x squared. Positive 9, because the 25's bigger. Okay. All right, your next step would be to bring down the next term and then start the next round. Okay. And when you go to the next round, you go back to the 3x, but now you're going to take the 9x squared and divide it by the 3x. So when you do, that's going to be just 3x, isn't it? So that's what goes right here, and it's positive. So put plus 3x. Okay. Then you're going to multiply back and take that 3x times the 3x minus 5. Okay. Right, when you do that, 3x gets distributed. So you get a 9x times x, which would be x squared. And then you get a minus 15x. All right, so that's going to go right here, 9x squared minus 15x. Now don't get ahead of yourself. All we're doing right now is the multiply back step. It's at this point I'm going to go in and think about trying to subtract the bottom polynomial from the top one. So that's when I go in and I change my signs so that I can add straight down. So 9x squared minus 9x squared, and then a negative 21x and a positive 15x would be a negative 6x. Okay, because the 21's bigger and it's negative, the 15 is positive, so that's why it looked like a subtraction problem. I was adding a negative 21 plus 15, and I would get a negative 6x. Okay, so we're ready to bring down the next number. This time we had to go 3 rounds because we were dividing degree 3 by degree 1. So there's 3 rounds of this. So we're done with the second round. Let's move on to the third. All right, so now we go back to that 3x again, but this time we divide it into negative 6x. And when you do, you get a negative 2. So we're going to put minus 2 up there. And that minus 2 gets multiplied back times the whole 3x minus 5. When you distribute the negative 2, you get a negative 6x plus 10. So it'd be negative 6x plus 10. Okay. All right, so now we're to the step where we're supposed to subtract. So I'm going to change that sign to a positive. This one would change to a negative. Oh, and again, that goes away, and so does that. All right, that doesn't happen all the time. It just did on 33 and 34. Okay, that 3x minus 5 just went into that evenly. There was no remainder. So your answer to that one would just be the 5x squared plus the 3x minus the 2. Okay. All right, but let's look at another one that has a remainder. 35 is tricky for a couple of reasons. Okay, so let's take a look at 35. Let's start with the blue. All right, so with 35, I gave you p to the third. Then I went and I did 3p. See how it doesn't have a squared on it? Oops, and that was 25. Minus 25. And I wrote it a little differently this time. I used the old-fashioned, or used the horizontal looking division. Means the same as if it was written above one another. Going to set it up like a long division since this has two terms, not just one. If that had been just one term, I could have done what we did at the end of the test. All right, so now we're going to set it up like a long division. So you're going to do p plus 7, and you're going to divide it into, but here's where you got to watch out. See how I went from a cube to the first power and you're missing the squared? You're going to need that squared term in there so that things will line up. So what I'm going to do is add in here a 0p squared. 0 times something is really 0. So that doesn't really change the problem. It just gives me like a place where I can line up the other p squared stuff. Now let me write in the rest of the problem. Okay. All right, so now we'll go ahead and get started on this. Let me find my calculator because I think this one gets kind of big. All right, so go ahead and get started. I'll get you started over here while I go find my calculator. So you're going to take your p to the third divided by p, which is p squared, goes here. And now, can you go ahead and multiply that back times the p plus 7 and then write it in the appropriate spot? I'll be right back. Okay, so when you did that, did you get p to the third plus 7p squared? So that should go right here when you multiply back. And if you're comfortable doing it without the scratch work to the side, that's okay too. It's just multiply back times both p and 7 and write that down. And see how if we didn't have that 0p squared, we would not have had a place to line up the p squared term. So that's why you had to put in that placeholder. All right, now you're on the subtract step. So you're subtracting this entire polynomial. So you got to subtract p to the third and subtract a positive 7. So that's going to become negative. P to the third and negative p to the third would cancel out. And then here we'd have a 0p squared and then a negative 7p squared that we're combining. So that's negative 7p squared. Okay, so you're done with the first round almost. You just need to bring down that next term. And then you're ready to get started, okay, on the next round. Okay. All right, so now we're going to go to the p again, but we're going to divide it into the negative 7p squared. So that just knocks out one of the p's, and you have a negative 7p, which should go right here. Now you're at the multiply back step, so that negative 7p gets multiplied by p plus 7. Okay, so that has to get distributed, and you wind up with negative 7p squared minus 49p. Now don't get ahead of yourself. Just go ahead and multiply and see what you get. Don't change the signs ahead of time. Wait until you see what happens. So this, when we multiplied back, we got a negative 7p squared minus 49p. Right? But now we're getting ready. Now we're getting ready to do the subtraction step. So that's when we're going to change the signs, because subtracting negative 7 would be adding. Subtracting negative 49 would be the same as adding 49p. So then the negative 7p squared and the positive 7p squared cancel out. And then you got to be careful and make sure you're focused on the new sign. Okay, so the positive 3 and the positive 49 become 52p. Okay, not negative 46. And then you bring down the next term, and this will be the last round. Okay, we'll follow those steps that we always follow. We'll have to do it 3 times. Okay. All right, so we go back to the p. but we're going to divide it into the 52p. And we get just 52. That goes right here. Okay. So when I multiply back, this is why I needed a calculator. I knew the number got big on this one. I have to multiply back by p plus 7. So I'll get the 52p. And then this time, I don't get a remainder of 0. Okay. See, this turns out to be 52 times 7 was 364. Positive 364. And that goes right here, 52p plus 364. Okay. Now we're at that subtraction step. So when I subtract, I distribute a -1 throughout, which changes the signs. This is gone. -25 and -364 don't make a positive because we're adding. We're going to get a -389. Rather than having a remainder of 0, we have a remainder of -389. Okay. So this problem is kind of like if you had taken 7 and we're trying to divide by 2. It could be written either one of those two ways. When you do that and you divide 2 into 7, it goes 3 whole times, but there's a remainder. And you remember how you use this right here to write it as a mixed number? 2 went in there 3 whole times and 1 half. So you don't just say remainder -389. What you're really going to do is use this information to write as almost like a mixed number. So you're going to take the quotient, which is p squared minus 7p plus 52. You know, what's on top goes there, right? Then you're going to take the remainder, which is the -389, and do what we did over here with the remainder. See where the 1 was on top of what you were dividing by? So put the remainder on top of what you were dividing by. And then the only difference is this is really 3 plus a half. We just say 3 and a half when we're reading it, but we don't usually write the sign. Here you need to put the sign. And since that's negative up there, it would have been okay just to say minus and then had 389. But you'll see it this way quite a bit. And then that's your final answer. So that's your quotient plus the remainder over the divisor. Okay. So those are the 3 problems that were on the review sheet that we didn't have to do on this test. Okay, but it gives you a few more examples. Okay, so I'm going to go ahead and get that posted for you.